Okay, so in our last video, we talked about finding general solutions. We talked about finding families of solutions to differential equations, but a couple videos before that, when we were doing slope fields, we were thinking about also particular solutions. We were talking about the kid of a family. And now we're going to get to that algebraically. So we did it graphically with both our family of curves and then our particular curve. And now algebraically we've done our family of curves. Now we're going to do our specific kid. We're going to find particular solutions. And what we need to find particular solution is first we need two pieces. We need our differential equation, and we also need an initial condition, which means we need a point. Okay, and the first part of this is exactly the same as what we did before. We're kind of just building on what we did. We're going to figure out what is our family, what is our general solution. So if I have dy over dx equals 4x, well, that's the same thing as dy equals 4x dx, just by multiplying dx to both sides. And then how do we get rid of these dy's and dx's? Well, we're going to integrate it, and I'm actually going to write the 1 so I know what I'm integrating on my dy side. What is the antiderivative of 1? Well, that's just y. What is the antiderivative of 4x? That's going to be 2x squared plus c. And this is already solved for y, so let's just plug in our initial condition. Since we have a y and we have an x, and we can find our c. So if I plug in my initial condition, 7 for y equals 2 times 1 squared plus c. 1 squared is 1, times 2 is 2, subtract 2 from both sides. We get 5 equals c. And now we can write our particular solution is just putting these two things together. So our particular solution is y equals 2x squared plus 5. And this is our specific solution to this differential equation. Okay, scrolling down. Yeah, we did 3 examples on this side. Why don't you go ahead and try this one on your own? And then I'll come back, and I think for this one I actually want to give us 2 ways to do it. Okay, pause the video, try this one on your own, see if you're able to do it. And when I come back, I'm going to walk us through this one. I'm not leaving us alone for it. Okay, so we have this differential equation and we have an initial condition, so we are able to find a particular solution. So let's just start with our separation of variables. We end up with y dy equals x plus 1 dx. Just multiply by dx and multiply by y on both sides. That gives us this. How do we get rid of the dy and dx? We integrate. What is the antiderivative of y? That's 1/2 y squared. What is the antiderivative of the square root of x plus 1? That's 1/2 x squared plus x plus c. And this is where we have two methods that we can go from here. They'll give us this, they should give us the same answer. But I'm gonna go ahead and show us both ways. So way one is going to be, this isn't solved for y yet, but we have an x and a y. We can just substitute in, that'll give us c. So way one, we're just gonna substitute in first. So I'm gonna take my initial condition and substitute that in, so we end up with 1/2 -2 squared equals 1/2 0 squared plus 0 plus c. And then simplifying this, we're going to get 2 equals c. I'm not going to do the math for that. And so then we can substitute the c back in. We get 1/2 y squared equals 1/2 x squared plus x plus 2. And the question is, are we done yet? We have this. But if you remember on our last video, we never left it with this y being by itself, and I don't want to leave it like that. I want to rewrite this so that y is by itself, and that's going to be my particular solution. So multiply everything by 2. We get y squared equals x squared plus 2x plus 4. Note that now that I've made c a number, a specific number, I do need to multiply it when I'm doing stuff to it. Every operation that we do now, since the c is 2, we need to do to that. And then here, we're going to take the square root to get rid of that. Y equals the square root. And remember, when we're doing a square root, we are losing the uniqueness of the sign, so we end up with plus or minus. And I'm actually noticing something here. X squared plus 2x plus 4. Is this factorable? Or actually, I say I'm noticing, but I'm thinking about it. Is it factorable? It is factorable, but is it factorable? B squared. Sorry, this is not factorable, actually. And we have y, this equals plus or minus the square root of x squared plus 2x plus 4. Can we figure out if it's going to be plus or minus? Well, let's look at our initial condition. When x is 0, y is -2. So let's plug in 0 again here. This is just going to go to 0. This is going to become 2. And do we want positive or negative? We want negative. So our correct answer, our particular solution in this case is y equals negative square root of x squared plus 2x plus 4. Because the positive one doesn't satisfy our initial condition. And if you remember in Algebra 2, when you were solving, I forget what type of functions it is. I think it's cubic functions. Or no, when you're solving square root functions, actually. You end up with extraneous solutions. And so in this case, this plus, this positive root would be an extraneous solution. It's an extra solution that doesn't make sense. Okay, so this is method 1. Method 2 is going to be taking the same process, except we're going to do it in a different order. So what I'm going to do is, instead of plugging in my initial condition first, I'm going to solve for y, and then I'm going to plug in my initial condition. And hopefully we should get the same answer. So let's solve this for y. It's going to end up with the same thing that we got here. This y squared equals x squared plus 2x plus 4. Or y equals the square root. Plus or minus the square root of x squared plus 2x plus c. Because I don't have 4 yet. And there's my y. Now let's plug in our initial condition. So y should be -2. So -2 equals plus or minus the square root of c. And then how do we get rid of the square root? Well, we square both sides. And we get c equals 4. And notice I didn't put a 2c there. I didn't multiply the c by 2 because it's just a constant, and I end up getting the same thing as this. And actually, if I had multiplied c by 2, I'd end up with a different thing here. I'm gonna have to explore that a little bit further to figure out some nuance on what our actual solution is going to be. But I'll say it's a general rule. Leave c alone. Because that'll probably lead you to a better path. Okay, and then we still have this same question. C is 4, but we still have the same question that we asked here. Which one will, this plus and minus, which one will satisfy our initial condition? It's still going to be, we want a -2, so we need this minus. So we get y equals negative square root of x squared plus 2x plus 4. Okay, and there's that one. 2 ways to do it, same answer. Third question. Which of the following is the solution with the initial condition y of 3 equals -2? Go ahead and try this one on your own. When I come back, I'm going to talk through this one quickly. I'm going to have all the work out and we're just going to go through it quickly. Okay. So same process as before. I chose method 1. I think method 1 is going to be a better method for y'all to use than method 2. So that's the method I'm probably going to use most of the time. Separate the variables. We get the integral of y dy equals the integral of x squared dx. We integrate this. 1/2 y squared equals 1/3 x cubed plus c. And now I have my x and y. I can substitute that in. I get 1/2 -2 squared equals 1/3 3 cubed plus c. Simplify that. 2 equals 9. C equals -7. Boom. And now I'm going back to my original function. I'm substituting this negative in here. So we get 1/2 y squared equals 1/3 x cubed plus -7 or -7. Multiply everything by 2. Square root is going to be plus or minus, and I'm noticing here that we want a negative number. Well, the only way to get a negative number if the negative is on the outside. So it's going to be a negative here. That gives us answer choice E. Okay, 3 more example questions, and I chose these questions because I think they're things we're going to struggle with. And I'm probably going to talk us through this a little bit. Okay, so they give us the general solution. They give us a differential equation and they give us the general solution. And we want to find a particular solution given an initial condition. So that first part is no different. So let's find this particular solution. We get negative square root of 2 equals plus or minus the square root of -2 squared plus c. How do we undo the square root? We square it, so we get 2 equals 4 plus c. c equals -2. So our general solution is y equals the square root of x squared minus 2. And then the question is it going to be plus or minus? Well, again, I'm noticing that my output is negative. The only way to have a negative output is if I have a negative in front here. So I get this. Fortunately, unfortunately, that doesn't help us that much. It allows us to eliminate b and d because those are the positive solutions, but we want the negative one. And now we need to think about what is our domain of this? Well, we need, can we take the square root of a negative number? No, we can't. So we need to say that this inside our square root, our x squared minus 2, needs to be greater than or equal to 0. I'm sorry, it needs to be strictly greater than. I was thinking about it. I was looking at the answer choices and I was like, why don't these have the greater than or equal to? Well, why does it need to be greater than? Let me pull up my notes really quick. Sorry, I have a thought in my head that I'm pretty sure is true, but I want to verify it before I say something that's not true in a video. Okay, I got the answer in my head. Why do we need to be strictly greater than 0? Well, if my y is 0, if I do end up with 0 here, what happens to our derivative? Well, our derivative is undefined there. So that makes, when our derivative is undefined, sort of side tangent, that makes the process that we did not work. So this separation of variables that we did to get this general solution only works where our derivative is defined. So we can't have y being 0, so we need to be strictly greater than 0. Okay, and then we keep going. X squared is greater than 2. X is greater than plus or minus the square root of 2. And we need to interrogate this a little bit more carefully again for the same reason that we can't be 0. This plus or minus, another way we could rewrite that is we could say this is the absolute value of x is greater than the square root of 2. That's a way to deal with this plus or minus. However, if I sort of draw that on a number line, we have negative square root of 2, positive square root of 2. That makes our solutions everything here. I think I'm explaining this a little bit confusing. But that would make our solution everywhere here. Okay, I had to think about this for a second. So for the same reason, our function is not differentiable at 0. When y is 0, that's why we have our strictly greater than. Well, our function is not differentiable on this interval here because it's undefined. It's not continuous, so it's not differentiable. And since it's not differentiable, we can't cross this gap. So we need to choose the part of this that is specifically with our initial condition. Similar to how we did over here, we chose one that satisfied our initial condition between the plus or minus. We're doing that same thing here. So we're choosing this negative one. I'm going to highlight it in blue so it should turn green if I'm correct. Yeah, see it turned green. I chose blue. So we only have this part of our domain. So lots of sort of confusing pieces here, but you can put a comment if you're if you need me to explain that better, because that's definitely not the best explanation I can give. Because I had to think through it really intensely myself. I'm just looking for my notes on this next one. Okay, this next one here, same type of problem, but it's a different function. Go ahead and pause the video, try and find the particular solution, and then I'll talk us through the domain, and I'll try and talk us through it a little more clearly than I did before. Okay, I'm coming back because I'm realizing we're gonna get stuck. When we get to this spot here, we're gonna get stuck. This is something new. So we have this quadratic on the left and a not quadratic on the right. We're going to do something very unintuitive. I'm going to subtract x minus x plus c from both sides. And we're going to... I don't know what to do with this. In terms of solving for y, but I am looking at this, and I sort of said it earlier, but this is a quadratic. How do we factor a quadratic? What is our method that always works? Well, let's try the quadratic formula. So y equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So our b is 1, so we have negative 1 plus or minus the square root of b squared. 1 squared is 1 minus 4. A is just 1, so I didn't write it. And c is this negative x plus c. Divided by 2. Let's simplify it to make it look a little prettier. We get y equals negative 1 plus or minus the square root of 1 plus 4 x plus c divided by 2. Oops. Do my line rolled. Okay. And now let's just go ahead and substitute in. Let's find our c. We have 0, 0, so 0 equals negative 1 plus or minus the square root of 1 plus 4c divided by 2. That just becomes 0 equals negative 1 plus or minus the square root of 1 plus 4c. That just becomes 1 equals plus or minus the square root of 1 plus 4c. Square both sides, we get 1 equals 1 plus 4c. we get 0 equals 4c. That gives us that 0 equals c. So we get this here, c equals 0. So then we're left with our particular solution is y equals -1 plus or minus the square root of 1 plus 4x divided by 2. And again, we'll evaluate the plus or minus, which one satisfies our initial condition. Well, we want -1. This is going to end up being 0. We want -1 plus this to equal 0. Well, -1 plus 1 is 0. -1 minus 1 is -2. So we want the positive version. So our particular solution is y equals -1 plus the square root of 1 plus 4x divided by 2. And that leaves us with only D as our answer. That's the only one that even makes sense. But just to sort of walk through the domain again, we want this square root of 1 plus 4x to be greater than 0. We'll square both sides. That doesn't do anything. We get 1 plus 4x is greater than 0. That just gives us x equals -1. X is, sorry, not equal to. X is greater than -1/4. And that's this right here. Okay, yeah. And notice our function is differentiable on this entire thing because where our derivative is not defined is where y equals -1/2. So we're not including that interval here because we're strictly greater than 0 for that. So this thing will always be greater than -1/2. Okay. Last one, talking about domain again, because that's going to be our tricky part. Go ahead and pause the video, and then come back and I'll talk us through it again. Okay, so hopefully we were able to at least get here. It does something a little tricky after you've found C, because you'd end up y equals -1 over x minus 2. Well, all they did is they factored out a negative, and then factor out a negative to switch the signs, basically 1 over 2 minus x. And now our question is, we're talking about here or here? Well, here we're asking, where's our function continuous? It's continuous when 2 minus x is not equal to 0, when our denominator is not 0. So what does that mean about x? It means that x is not equal to 2. And that's where I get this number line here. But we have a similar situation to what happened up here, where there's a gap, there's a hole in our continuity. Or I'm sorry, let me rephrase it. There's a hole in our differentiability. It's a hole in our continuity as well, but we're not continuous at 2, so we're not differentiable at 2. So that means we can't cross this gap. So which side of this follows our initial condition, where our initial condition is x is 1, so that's going to be here. So our solution is this part right here, because we can't cross this gap where we're not differentiable, and that would be D. I'm going to end up doing another video on this one, going through a FRQ question, or maybe two. I want to come back and revisit this domain and kind of clear it up a little bit and hopefully make it a little more apparent, because I think I skipped steps that will be confusing. But thank you for watching.